Hi friends, this is Dr. Reddy and you are watching Dr. Reddy's Chemistry World. Friends, in this video I am going to discuss about the concept of dipole moment. See friends, di means two poles, dipole means two poles or two opposite charges. For example, in case of hydrogen fluoride, so hydrogen is less electronegative element, fluorine is more electronegative element. The electronegativity values of hydrogen is 2.1 and fluorine is 4.0. Due to this electronegativity difference, fluorine attains a partial negative charge on it and hydrogen attains a partial positive charge on it. Okay, now these two opposite charges we call them as dipole. Similarly, in hydrogen chloride also there is a partial negative charge developed on chlorine and there is a partial positive charge developed on hydrogen. Now this we call it as dipole. Similarly, in methyl fluoride and methyl chloride also you can observe dipoles. Okay, now all these dipoles are same? No, they have a characteristics dipole moment values. Okay, see for example, for this dipole the dipole moment value is 1.1 d and for this dipole the dipole moment value is 0.81 d and for this dipole the value is 1.82 d and for this dipole 1.95 d. So dipole moment depends on two things. One is charge on the dipole and the other one is distance between two opposite charges or distance between dipole. Okay, so mathematically dipole moment expressed as follows. It is a product of charge and distance between dipole. Okay, so A units for dipole moment is d by, it is the honor of this scientist, so who measured dipole moment for molecules. So on the honor of this they are denoted with the symbol capital D. So 1 d is equal to 10 to the power of minus 18 ESU centimeter in case of CGS units. In case of SI unit, 3.33 into 10 power minus 30 coulomb meter. This is very important values and competitive also very important. So please make a note on this. See, previous we discussed dipole moment depends on two things. One is charge and the other one is distance between them. Okay. So now coming to these examples, see in hydrogen chloride. So hydrogen fluoride has more dipole moment than hydrogen chloride. See, because in hydrogen fluoride more charge is developed. Okay, because of more electronegativity difference between this hydrogen and fluorine. So here the electronegativity difference is almost 1.9, but whereas in this case electronegativity difference is 1. Okay, so more electronegativity difference is there, so more charge develop on these elements. So more charge develop, more dipole moment values are observed. Okay, now coming to the next example. So here also in case of methyl fluoride, okay, more electronegativity difference is there, almost 1.5. So here electronegativity difference is 0.6, but the dipole moment values are the one which is having less electronegativity difference, that one has more dipole moment value, and the one which is having more electronegativity difference has less dipole moment. Okay, the reason is here dipole moment not only depends on charge, it also depends on bond length or distance between dipole. See here this distance is less, here distance is more, so it also depends on what? Distance. Okay, that's why in this case both factors are affecting. Okay, one is charge and also distance. Okay, that's why methyl chloride has high dipole moment.